Hello everyone. So in this session we'll see another problem on area by double integration for the Cartesian coordinates. So let's say the question is something like this. We have to find the area of the region in the two dimension where x and y are defined, with the x being between -1 to 2 and y belonging to x squared to x plus 2. So we don't, it's not required that we need to draw a diagram here. We can clearly understand that the limits for x is from -1 to 2 and the limits for y is going to be from x squared to x plus 2. So even if we are not drawing the diagram, we can say that the area required will be given as the limits for x -1 to 2 and the limits for y x squared to x plus 2. So this is dy dx. That's it. From here we can do the double integration. The limits are already known and therefore we'll get the value. So let's start with the integration in terms of y. In that case, dy integration will be y with the limits x square and x plus 2, and the whole thing gets integrated with respect to x with the limits from -1 to 2. So putting the limits, it is going to be x plus 2 minus x square, and this thing gets integrated for -1 to 2. Now x plus 2 minus x square. So integrating this, we'll have x square by 2 plus 2x minus x cube by 3, and the limits -1 and 2. So for 2, this is going to be 2 square, which is 4, 4 by 2, which is 2, 2 times of 2, which is 4, minus 2 cube, so minus 8 by 3, minus 1 square will be 1 by 2, and minus 2 and minus cube will be minus, and minus plus, so plus 1 by 3, like that. So this is 6 minus 8 by 3, minus 3 by 2, so plus 3 by 2 and minus 1 by 3. So 6 plus 3 by 2 will be 15 by 2 minus, so 8 by 3 and 1 by 3 will become minus 3. So 6, and that is 9 by 2, just 4.5. So the area required here is 4.5. So I hope this is clear. We didn't have to do the diagram. We didn't have to do the intersection. We could directly see the limits from the region defined here, and therefore we could directly integrate and find the value. That's it. So I hope you understood. Thank you.